Welcome, Professor Bright here, and we're going to just do a quick review of functions. Again, in the other videos, you maybe heard trigonometric functions, and you're like, oh, I haven't talked about functions in a while. What is all that stuff about? So here we go. A function we can talk about, but even before that, we need to talk about some precursor terminology, and that is relation, domain, and range. So a relation, strictly speaking, it's kind of an abstract thing, but it is just a set of ordered pairs. Okay, so notice that there are x and y values in a relation. So we have an element x and it's somehow related to y and vice versa. Okay, now within this relation, we talk about those x values as being the domain values, inputs. Okay, so inputs. Okay, and similarly, we talk about the set of all y values as being the range elements, and sometimes you just call those outputs. Okay, and so we have to have these elements in order to talk about a function, and a function is a particular type of relation where we also have this condition. For each value of x, there's exactly one y. Okay, so just to illustrate this, imagine we have x1, x2, x3, and then y1, y2, y3. And let's do this twice. Okay, so a function would take, okay, so if for each value of x, there's exactly one y. So if x goes to y1, x2, let's change it up, x2 goes to y3, and x3 goes to y2. Okay, now this would be okay. And then an example of not a function would be something where maybe we retain the idea of x2 going to y3 and x3 going to y2, but we have x1 going to two different y values, okay? And an easy way to, so analytically, you're like, okay, I kind of get it, but some of us learn better by pictures. I know I do. So if we put this in pictorial form, we might say, okay, well, we have, let's just say we have this function, so it's maybe some kind of cubic, I don't really know, but we're going to give this a name y equals f of x, okay? In other words, we obtain the y value by doing something, doing a function on x. So we put in x, we get out y, okay? Now, pictorially, how we test for a function is if we can take vertical lines through any place on the function and we hit the function at most once. That's called the vertical line test. Okay, so this one would get the stamp of approval and say, yep, that is a function. On the other hand, if we look at a function, let's maybe look at an ellipse centered at the origin, okay, if we take a line through that, right, we hit in two different places. So this is going to fail the vertical line test, and we would say that the ellipse is not a function. Okay. So conceptually, yeah, it might seem easy if we can get to a picture. Now, determining it without a picture, that could be a little bit more of a challenge. And so here's just a brief example of how we might go about this from an algebraic perspective. So we have a function given like this, and we get to do maybe one of my favorite F words in math, factor. Yep, factoring is fun. So we factor the numerator and denominator, x minus 2, x plus 2, and then the denominator is going to be x plus 2 x plus 4, okay? And then you can say, oh, well, there's a common factor, reduce, right? And you can say that this f of x is actually x minus 2 over x plus 4, okay? So, yep, you did some factoring, you had fun, and you get this, right? So then when it comes to talking about domain and range, okay, we'll talk about domain and we'll talk about range, okay? And I'm going to use the symbol D of F for domain. okay? And I'm going to say it's all real numbers, so this is an abbreviation for all real numbers. And then I'm going to say this slash for except or remove. So I'm going to say it's all real numbers, and then I just have to figure out, okay, what x values can I not have? Well, looking at this thing, I don't think I can have -4 because that'll make the denominator 0. Okay, you would be almost correct. In fact, you'd probably be 95% correct. The only thing that you're forgetting is that at the very beginning, the original expression before we reduced, we had an x plus 2 in there. So if we hadn't had the foresight to reduce right away, we also could not have a -2 in there. Okay, so we have to actually factor at the very beginning, find the domain, or find those things that cause us to divide by 0 or make the function undefined, and take those. So that's more of an algebraic route. You can express it in this form. You will be working with interval notation quite a bit. So if you can imagine this on a number line, you would have, okay, let's put 0 on there, and we have -2 and -4 wonky things happen. We have holes there, right? We don't have the function defined there, but we would have the function defined everywhere else. Okay, so pictorially it would look like that, and I find that this form is easy for us to write, or easier perhaps, for us to write out the interval notation. So we'd have the first interval being from -infinity to -4, join that or union that with the second interval, which is from -4 to 2, and I'm using parentheses to indicate exclusion, and then union that with this third chunk, which would be from -2 to +infinity. Okay, so different ways of expressing the same thing. Check for the desired notation and run with it. Okay, for me, generally, if you express it in one form, I'm good. All right, so now the range. The range is going to be a little bit trickier, and generally what I'm going to say is look at the range by looking at the graph, okay? And specifically the y values on the graph, okay? Mathematically, what this ends up being, if you remember from your pre-calculus studies or maybe Algebra 2, Advanced Algebra, this ends up being all real numbers except wherever you have a horizontal asymptote, because this comes from a rational function. So this ends up being all real numbers except in the horizontal asymptote is going to be at y is equal to 1. Okay, and so again, if you wanted to put this in interval notation, this would be all real numbers except for +1. Oops, 1 to infinity, union that together, and that would be our range. Okay, and so just a reminder that we use parentheses to indicate inclusion and brackets. Sorry, I have that reversed. Exclusion. And brackets or square brackets to indicate inclusion. So parentheses, exclusion, square brackets, inclusion. Okay, so now this is another way that we could find domain and range. Okay, and there's another task. So I actually want you to see if you can pause the video and try and find the domain and range. And then if you are super motivated, you can list the intercepts, which that actually generally goes quickly. And then it says, what else? Find f of 1, and then x such that, and that's my abbreviation for such that, f of x is equal to 1. Okay, pause video, try it out. And here are my answers. So domain, right, that's all your x values, okay? This goes left to right by default, okay? Because x values, right, we start counting on the left and then we increment as we go to the right. So start at -4, that is included because we have a filled in dot. Continue up until 0, we have a hole there, so that's why I have a break. And then I have to infinity. What happens at 3, right? Well, we have a closed dot and an open dot. Remember that a closed dot supersedes a open dot because the closed dot means we have the value. So that's why I just continued on. Range is the y values. Okay, so y values start down at -1 again. So this one is up, down to up. Okay, so start down at -1, continue on upwards at +1, right? I didn't have a break. That's because I actually have a filled in dot here, right? If it isn't shown, assume that there's a filled in dot. Filled in dot supersedes a hole. Okay, continue on up. 2, have a break, yep. And then why is 3 in squiggly brackets only? Because there's just a single value. If I'm looking at the vertical values, y, it's just 3. I don't have anything beyond 3 in either direction. Okay, so that's why you include 3 in curly braces. Intercepts, I only have the point 1, 0 because I have a hole at 0, 1. F of 1, so this is saying x is equal to 1, right? So when x is equal to 1, y is equal to 0. Other way around, right? This 1 is y. So now if I look at this, y is 1 exactly here, and that occurs when x is 2. So very, very brief overview of how functions operate and some other properties within functions. If you have more questions, feel free to take a look through the book. There is undoubtedly a section on functions. If you have further questions, I'm happy to help you in person.